Okay, so in this problem, I'm going to be doing question number 13. So this is two charges are located. So we're told that there are two charges. So we have two charges. So this is number 13. So we're told that Q1 has a charge value. I'm going to do two significant digits only. So it's 4.0 coulombs. So it's 4.0. So remember, standard units is kilogram, meters, second, charges in coulombs, magnetic fields are in Teslas, whatever. These are standard units. So whenever you see a charge and it's 5.0, for example, that'll be 5.0 coulombs. Okay, and Q1. So we have a charge Q2, and it's got a value of minus 5 coulombs. Okay. And we're told that the charge in space, right, has 3, 4, 5. So Q1 is located at 3, 4, and 5. And charge Q2, it's located at, so 3, 4, 5 means it's 3 meters in the x direction, 4 meters in the y direction, 5 meters in the z direction. And it's the second point is negative 2, 2, 3. So the question is find the force on find the force 1, 2. So find the force of 1 acting on 2. Okay, and also find the force of, so trying to find the force 1 acting on 2. So the force of 1 acting on 2, and let's actually, before I do that, let's make sure that you understand. So in space, right? So somewhere in space we have two particles, Q1 and particle Q2, and we want the position vector R is R1, and the position vector for this is R2. So the vector drawn from R1 to R2, the diagram's terrible. Okay, so this is Q2, so this is really the arrow drawn from 1 to 2. Okay, so let's calculate R12. R12 in this case, right, is given by position vector of R2, I'm sorry, minus the position vector of R1. So how do you get to R2? R2 is minus 2 meters I plus 2J plus 3K. So it means that from the origin I have to travel negative 2 meters in the I direction, 2 meters in the J direction, and 3 meters in the K direction. And R1 is going to be 3I. Is it on the board? Yeah, it's on the board. 3I plus 4J plus 5K. So the I component happens to be minus 2, minus 3, so this is minus 5, plus the J component is going to be 2 minus 4, which is minus 2, and the K component is going to be 3 minus 5, which is negative 2. Okay, so that's R12. What is the force of charge 1 acting on 2? And that's equal to K, the Coulombic constants of KQ1 times Q2 over the distance between them, which is R12 squared, times R12 directional vector, the direction vector from 1 to 2. So this is the force of charge 1 acting on 2, the force of 1 acting on 2. So let's do the calculation for R12 hat, the directional vector. So basically we have to take R12 vector, take this vector and R12 and divide it by the magnitude. So we have a directional vector. And so this is minus 5I minus 2J minus 2K, all divisible by square root of the magnitude. Magnitude is minus 5 squared plus minus 2 squared plus minus 2 squared. Okay, so what is the actual force? We can actually start plugging everything in because we know what R12 is. R12 is just the magnitude, so we can write these things in. So I won't try to reduce these because I'm really looking for the steps involving the equations. These are time-consuming calculations. Nobody wants to spend time doing these. But so on an exam, it's 9.0 times 10 to the 9 units. For K, we know it's actually newtons meters squared per coulomb squared, but don't use those units. Okay, it's just the natural units were in kilograms meters per second, so it's 9.0 times 10 to the 9 is Coulombic constant Q. Q1 happens to have a value of 4.0 times minus 5.0, and all divisible by the magnitude of R12, which is this squared, which is minus 5 squared. I'm not going to reduce these numbers because this is really the steps involved, because nobody wants to do these calculations in real life. And this is R12, and we square it, times the directional vector, which in this case happens to be minus 5i minus 2j minus 2k, all divisible by square root of minus 5. Same thing over here, so you can actually say it's cubed, but I'm not going to go any further than this. Okay, so this is F12. Now I can repeat the process for F21, but the main idea you're going to get across by Newton's laws, these are all Newtonian mechanics. The force of 1 acting on 2 is the reaction negative of the force of 2 acting on 1. That's action. The action force is the negative of the reaction force for the third law of Newton's laws. So that's really minus 2 acting on 1. I can do the calculation, but it'll be the same thing. And you might have noticed that this is actually the square root is cubed. That's fine too. So a lot of times people actually write, nobody wants to do this calculation of the unit vector because you have a lot of square roots. So people like to take this equation and say it's really k q1 times q2, and R12 is really R12 divided by, so this is really R12 cubed times R12 arrow. It's the same equation, and a lot of times I'm lazy and I just prefer to use this equation, but most textbooks always go with this, but when I'm lazy I just feel like writing this because I know it's going to derive to the same thing. But either way, I'll expect that you are able to do these calculations. You don't have to go to a calculator and do these numbers because I'm not testing you on how fast you can plug these into a calculator. My purpose is to make sure you're understanding the idea. So physics is about ideas. It's not about like how fast you can plug into numbers into a calculator.